My name is Romit Kakadia and I am student of Charoset University CSPIT CSE department. Today we are going to discuss about case study based on application of digital electronic in medical devices. Case study related to pacemaker, ECG monitor, digital thermometer. So now we discuss about what is digital electronics. That is one tagline which is related to digital electronics in medical devices. When every second count, digital precision save life. Now we discuss about what is digital electronics. That the circuit use binary signals 0 and 1 for operation. Second is important in medical device for precision, automation, and efficiency. Third one is real-time monitoring and data processing, wireless communication. Now we discuss about importance of digital electronics in medical devices. The use of digital electronics has made medical devices smarter and more efficiency. Doctor can now monitorize patient in real time, detect issue early, and make faster decisions. Devices are also portable and can store patient data, making long-term tracking. Now we discuss about overview of key medical devices. First one is the pacemaker that you can see here. Second one is the ECG monitor. Third one is digital thermometer. The pacemaker that control heartbeats, the ECG monitor that record heart activity, and the digital temperature that measure body temperature. Each use digital electronics to function precision. Now we discuss about what is a pacemaker. Pacemaker. A pacemaker is a small electronic device important in patient chest and to regulate abnormal heart rhythm. It helps the heart maintain a normal rhythm by sending electrical pulse when the heartbeat is too slow or irregular. Basically, the pacemaker divides three parts. First one is generator, second one is battery, third one is different type of sensor. Now we discuss about how its pacemaker works. So first is sensor detect heartbeat. The pacemaker monitor heart rhythm in real time. Second one is analyze in regulation. If the heart beats too slow, it active. Third one is sense electrical pulse. Deliver a small electrical signal to simulation heartbeat. Fourth one is ensuring normal heartbeat function. Help monitorize proper blood flow and prevents complication. Now we discuss about how a pacemaker works. Pacemaker, a pacemaker continuously monitors that heart's rhythm through electrons sensor. If it detects a abnormal heartbeat, the MCU process the data and decision if intervention is needed when required. It trigger the pulse generator which sends a small electrical impulsion to the heart via electrodes, restoring a normal rhythm. ADC or DAC convert signal between analog and digital function with logic gates ensure actually processing the memory. The memory unit store patient data for adaptation adjustment. This automated cycle help regulation heartbeats and ensure proper blood circulation. Here you can see circuit diagram of pacemaker and what is flow diagram of pacemaker. Now we discuss about key digital electronic component in a pacemaker. The pacemaker include a low power microcontroller, sensor, logic circuit to control operation, battery for long term use, memory to store data, and sometimes wireless module for remote monitoring. Here you can see that two image is wireless pacemaker, and third image is getting information of different type of sensor and CMOS chip, capacitor, and what is a logic gate circuit is mentioned here. Now we discuss about what is an ECG monitoring. Electrocardiogram monitor is device used to measure the record the electrical activity of the heart over time. It helps doctor diagnose and monitor heart conditions by analyzing the electrical impulses generated by the heart activity. Now we discuss about how its basic work. First one is hospital ECG machine. Large device with multiple leads for details cardiac. Second one is portable ECG monitor. That compact handheld device used for quickly monitoring. Third one is wearable ECG devices. Offer real-time ECG readings for personal. Now we discuss about how ECG monitor work. The heart, the heart produces electrical signals that control its con- contraction and relaxation. Those signals pass through the heart muscles and can be detected using electrodes placed on the skin. The ECG machine captures their signals and display them as a waveform, show that heart rhythm and electrical activity. The body electrical signals are captured by electrodes, amplified, and converted into digital form using an ADC. The microcontroller processes the data and display it on a screen as a waveform. Here you can see ECG waveform with circuit diagram. Now we are discuss about digital component in ECG. The ECG system records the heart's electrical signal using electrodes, which capture real-time cardio activity. These, these weak signals are amplified and converted into digital form using ADCs, allowing precision processing by the microcontroller unit (MCU). The MCU analyzes the data, detect abnormality like rhythm and second the result through a digital LCD display. This entire process combines analog signals with diagram electrons for accurate, non-invasive heart monitoring. ECG, ECG monitors are widely used in hospital, ambulance, and wearable devices. Now we discuss about electrodes that capture heart signal. They take electrical impulses from the heart, convert convert physiological signal into electrical signal. Now we discuss about different type of digital component in ECG. Amplifier and ADC. Amplifier puts the low voltage ECG signal to a boosts the low voltage ECG signal to a readable level. ADC converted that analog ECG signal into a digital format as assumed for digital processing by MCU. Now we discuss about MCU. That's microcontroller unit for processor that executes digital logic and, and handles data acquisition, handles data acquisition, signal filtering, analyze, and decision making. The MCU is the central digital brain of the ECG monitor. Third one is an LCD display. Third one is LCD display. Display that process ECG waveform, heart rate, and alarm alerts that interact directly with the microcontroller via digital data line. Now we discuss about what is a thermometer. Thermometer. A digital thermometer measures body temperature using sensor. It's available in Connect from like Boreal thermometer and in Connect from like IR thermometer, which are faster and safer than mercury-based ones, which are faster and safer than mercury-based ones. First one is measure body temperature quickly and accurate comes in connect contact and non first one is measure body temperature quickly and accurate comes in contact and non-contact form. Second one is replace traditional mercury thermometer, safer, more hygienic and eco-friendly. Third one is display temperature digitally, often in both Celsius and Fahrenheit. Now we discuss about how a digital thermometer works. First one is sensor detect heat. First one is sensor detect heat. The thermometer use a thermistor or an thermometer use a thermistor or a infra infrared sensor. The thermometer use a thermistor or a infrared sensor. This sensor measure the heat ampli amplified by the body. The output is an analog signal. Second one is analog signal to digital signal. The analog, the analog signal is passed through an amplifier to boost its strength. Then an ADC, analog to digital converter, converts the signal into a digital value that a microcontroller can understand. Third one is MCU processing the data. MCU, MCU unit receive. The MCU, the microcontroller unit MCU receive the digital signal. It runs It runs a programmed algorithm that converts the digital signal into a temperature reading. It may also add logic for favor, detect, beep, alert, or unique conversion in Fahrenheit or Celsius. Fourth one is result display on LCD. The calculated temperature is sent to the LCD display. The result is shown in digits, often with additional symbols. Ex- its example is thermometer icon, low battery, or favor alert. Now we comparison both three devices. Now we discuss about pacemaker. Purpose is control heartbeat. Main part MCU. Output electric pulse. Now we discuss about ECG monitor. Purpose is record activity. Main part ADC electronics. Main part ADC electronics. Output ECG graph. Thermometer. Purpose is measure temperature. Main part thermistor. Output is temperature is Fahrenheit or Celsius. Digital electronics from the backbone. Digital electronics from the backbone of modern medical devices, ensuring accurately reliability and compact design. Through their amplification difference, All three devices rely on key digital components like microcontroller, ADC, and sensor. Those components work together to monitor, measure, or regulate a critical body function in a real time. Integration of a digital system ensure that better patient care, faster diagnosis, and smart healthcare solutions. Now we discuss about future of digital electronics in health. Digital electronics is sharp in future medical technology, enable fast, smarter, and more precision healthcare solutions. First one is AI-powered diagonals, high-speed processor, memory units, digital sensor processing. Second one is wearable IoT health devices, sensors, microcontroller, wireless modules, battery system. Third one is smart implants, monitorized MCUs, ADUs, RF circuit, low power chip. Fourth one is remote healthcare and telemedical. IoT enable hardware, data encrypt chip, cloud interfaces. Now we discuss bring it all together. Digital electronic in action. Pacemaker. Control irregular heartbeats using electrical parts. ECG monitor. Record and display heart's electrical signal. dig- Digital thermometer. Measure body temperature digitally. All three devices use core digital components like sensors, ADC analog to digital converter, and MCU microcontroller unit. In conclusion, digital electronics are the hidden heroes include the world's most important medical technology. They bring precision in diagonals, automation in treatment, innovation in patient monitoring. Digital electronics aren't just complements, they are lifesavers. Thank you for attention.